Today we're working on exponents and division, so make sure you title your notes. And the first example we're doing here is 4 to the 5th divided by 4 squared. So remember, when you have a base with an exponent, it means you're taking that base and multiplying it by itself that many times, which is 5 in the numerator, 2 in the denominator. So that would be 4 times 4 times 4 times 4 times 4 in the numerator and 4 times 4 in the denominator. Now remember, we talked about this in class already, but if you have the same thing in the numerator as the denominator, they cancel each other out. So this 4 would cancel out with this 4. Now quickly, let me explain why. If you were simplifying a fraction, I'm just taking this one section of it. Let's just say it said 4 over 4. Well, 4 and 4 are both divisible by 4. 4 divided by 4 would be 1. 4 divided by 4 would be 1. So that's why these ultimately cancel themselves out, because 1 times anything, or 1 divided by, or anything divided by 1 is itself. So that's why we can get rid of those. So we could do that again. These 4's cancel. So now what we have is 3 4's in the numerator and nothing in the denominator. So that would be 4 times 4 times 4 in the numerator over, now remember when these canceled, they canceled to be 1's, and 1 times 1 would be 1. But anything divided by 1 is itself, so you don't need to write that. So all you would write is 4 to the 3rd power, because that's 4 times 4 times 4, which is what we had left here. Now you're actually not done with this problem yet, because when you have a number with an exponent here, we can still simplify this. So you could type that in your calculator, and 4 to the 3rd power equals 64. That's your final answer. All right, let's take a look at an example with variables now. A to the 4th divided by a to the 6th. So in the numerator, we would have a times a times a times a, and in the denominator, a times a times a times a times a times a. So these two will cancel each other out. These will cancel. These will cancel. These will cancel, so we are left with 2 a's in the denominator. Now be careful here. When you take a number and divide by 1, so something, anything, let's say 6 divided by 1, it's itself, 6, so you don't need to write the 1. But if you have a 1 in the numerator, you have to keep that, because that's not the same thing as 6 divided by 1. So in this case, since we have nothing left in the numerator, what we really have is a 1. Because remember, when these a's canceled, they actually canceled out to both be 1. So 1 times 1 times 1 times 1 would be 1. You have to write that. And then in the denominator, we have a times a, which would be a squared. That is our final answer, because we don't know the value of a, so you cannot simplify that anymore. So now if you see the pattern, since we are dividing with powers that have the same base, think back to what we did with multiplication. You might catch the pattern already. The way that you do this, dividing powers with the same base, it says to divide numbers or variables with the same base, you subtract the exponents. So make sure you write that down. Remember, when we were multiplying numbers or variables with the same base, we added the exponents. That was with multiplication. So you could see the connection here. Dividing, you subtract. Multiplication, you add. And then if we look back at the examples that we did here, let me go back to this slide. We had 4 to the 5th divided by 4 squared, so our answer was 4 in the numerator, because there's more 4's in the numerator. And then 5 minus 2 would be 3. And then just a 1 in the denominator, because there's nothing left, and that would cancel, which is what we got here. If you look at what we got for the a's, there are more a's in the denominator, so you have to have the a in the denominator, and then 6 minus 4 would be 2, but you need something to keep the place in the numerator, which would be a 1, which is the answer that we got there. So now let's look at another example here with numbers, coefficients, and variables. So 12m to the 5th divided by 3m. All right, first, before we even try to solve the variables, which is probably easier for some of you at this point, we are going to simplify the coefficients, the numbers in front of the variables. So think back. 12 and 3. A common factor of 12 and 3 would be 3, so we'll divide by 3 in the numerator and the denominator, and we will get 4 over 1 because 12 divided by 3 is 4, 3 divided by 3 is 1. I did not change the variables because I wasn't even thinking about those yet. So now to use the little trick that we just did, we would keep the 4 in the numerator, the 1 in the denominator, and then since we have the same base, they're both m's, we can subtract the exponents. However, there's no exponent here. So remember, if you don't see an exponent, you just see a variable, the exponent is going to be 1. Now since there are more m's in the numerator, there's 5 m's in the numerator, only 1 m in the denominator, that means my m's will stay in the numerator because there's more of them. And then I just subtract 5 minus 1 is 4. Now remember, since I ended up with only having a 1 in the denominator, I don't even need to write that, so my final answer would be 4m to the 4th power. Since I don't know the value of m, this is my final answer. So that's it for today.